Hello everyone, I'm Harith, your AI co-host for today. Interrupts are our topic of discussion, and I'll be guiding you alongside 5 brilliant presenters. Are you ready? Let's dive in.
Thank you, Harith. So, what exactly are interrupts? In simple terms, interrupts are signals sent to the CPU that temporarily halt its current work to address something more urgent. Think about it this way. You're deeply focused on a project and suddenly your phone rings. That phone call is like an interrupt. It demands immediate attention, pausing what you were doing. Now, in computers, interrupts are divided into two main types. The first one is hardware interrupts. This comes from external devices like keyboards or mice. For example, pressing a key sends a signal to the CPU to say, "Hey, I need your attention." The second type is software interrupts, which are triggered by programs. Imagine you're using an application and it needs to access a file or perform a task. It sends a software interrupt to request help from the CPU.
So, Aiman, would it be fair to say that interrupts are like priority alerts for the CPU?
Exactly, Harry. That ensure the CPU address what's most important first, keeping everything running smoothly.
Got it. This explains why computers feel so responsive, even with multiple tasks happening simultaneously.
Right. Without interrupts, that level of responsiveness wouldn't be possible.
Building on Aiman's explanation, let's explore why interrupts are so important. Without them, computers would rely on a method called polling, where the CPU constantly checks devices to see if they need attention. So, imagine being a teacher in a classroom. Instead of waiting for your students to raise their hands, you go around asking each one if they need help. That clearly wastes a lot of time and energy. That's polling. Interrupts, on the other hand, are like students raising their hands when they need help. The CPU doesn't have to waste time constantly checking, it simply attends to the device when it sends an interrupt.
That sounds so much more efficient, Alya. But can you give us a practical example?
Yes, sure. So let's think of a printer. If the CPU had to constantly ask the printer, "Are you ready to print?" it wouldn't be able to do much else. Instead, the printer sends an interrupt when it's ready and the CPU handles it right before it returns to its previous task.
So interrupts allow the CPU to multitask effectively.
Exactly. That's the secret to making modern computing fast and efficient.
Great points, Alya. Now let's move on to the actual representation of how interrupt works. It's a step-by-step process. So first of all, a device such as a keyboard will send a signal, an interrupt signal, to the CPU. Step 2, the CPU pauses what it's doing and then it saves its current state. Why do we need to save it? Because this will ensure that the progress will not be lost and then it can be picked up later after the interrupt process is finished. And then step 3, the CPU runs a special program called the ISR, which is the Interrupt Service Routine. So ISR is to handle the interrupt. And then the final step is when the ISR is complete, the CPU resumes its previous task.
That sounds pretty seamless, Julia. But what happens if the CPU is handling another interrupt when a new one comes in?
Good question, Harith. That's where interrupt priority comes in. Zakwan will explain that later, but to simplify, the CPU can decide which interrupts is more urgent and will handle it accordingly.
Like pausing your movie to answer the doorbell, and if the doorbell rings again, checking if it's more important than the first visitor?
Exactly. This prioritization ensures that the CPU stays efficient while addressing critical tasks.
Thanks, Julia. Now let's talk about interrupt priorities and their types. Not all interrupts are treated equally. Some are more urgent than others. For instance, a fire alarm takes priority over a doorbell. In computing, we categorize interrupt into maskable and non-maskable types. Maskable interrupt can be temporarily ignored if the CPU is busy with something more critical. For example, notifications on your phone can be muted. Non-maskable interrupts, on the other hand, demand immediate attention. Think of this as emergencies, like a fire alarm. The CPU stops everything to handle them right away.
So, Zakwan, how does the CPU decide which interrupt to handle first?
Great question, Harit. Each interrupt has a priority level. The CPU uses this priority to decide. High priority interrupts are handled before lower priority ones, ensuring that the most urgent tasks are addressed first.
That makes sense. It's like having a to-do list where emergencies jump to the top, automatically.
Exactly, Harit. This system keeps the CPU organized and efficient.
To wrap up, let's compare interrupt and pulling. Pulling is when the CPU repeatedly checks if each device needs help. Imagine a teacher constantly asking students, "Do you need help?" It is so inefficient and time-consuming. Interrupt, on the other hand, are like students that are raising their own hands when they need assistance. This way, the teacher, like CPU, can focus on teaching and only respond when necessary.
That's a great analogy, Amni. But why are interrupts better than polling?
Because it saves time and resources, Haris. Instead of wasting the energy on constant check, the CPU will only act when they are required. This makes the system more faster and efficient.
So it's like working smarter, not harder?
Exactly. That's the benefit of interrupts. They keep everything running smoothly and without wasting the resources.
Before we end today's session, let's take a moment to summarize all the key points we've covered. First, Aiman introduced us to interrupts, explaining them as signals that temporarily halt the CPU's current task to address something more urgent. We learned that interrupts can come from external devices, like keyboards or mice, or be triggered by software programs, which are essential for keeping everything running efficiently. It's like getting an important phone call that demands your attention, pausing your current activity. Then Alya highlighted why interrupts are crucial. Without them, we would be stuck with polling, where the CPU repeatedly checks for tasks. Interrupts, on the other hand, save time and resources by letting the CPU focus on more critical tasks only when needed, like students raising their hands instead of the teacher asking each one individually. Julia then walked us through how interrupts work step by step. It's a process where the CPU pauses, saves its state, runs the interrupt service routine, ISR, and then continues its previous task. But what happens when another interrupt comes in? That's where Zakwan came in with an explanation of interrupt priorities. Interrupts are categorized based on their urgency, with some needing immediate attention, like a fire alarm, and others able to wait, like notifications on your phone. Finally, Amni wrapped up by contrasting interrupts with polling. We saw that polling is inefficient because the CPU is constantly checking, whereas interrupts are much smarter, allowing the CPU to work more efficiently and only act when necessary. So, to sum it all up, interrupts are the secret sauce that makes computers responsive, efficient, and able to multitask without wasting resources. They allow the CPU to focus on what's most important at the right time, all while ensuring everything runs smoothly in the background. That's the magic behind modern computing. Thank you, everyone, for your insightful contributions today. And a big thanks to you, our wonderful audience, for tuning in. Stay curious, keep learning, and remember, whether it's about interrupts or any other tech topic, there's always more to explore. Take care and see you next time. Inshallah.